Good morning, good afternoon, and good evening. My name is Nolan Green, Senior Marketing Manager at NetBrain, and we welcome you today to our webinar exploring the latest NetBrain release, Problem Diagnosis Automation System powered by 10.1. I am joined today by Song Peng, SVP Engineering, and Raj Jain, Pre-Sales Engineering Demo Lead for NetBrain. Before we dive in, I just have a few housekeeping items. This webinar will last approximately 1 hour, and we will take all questions at the end. Please submit your questions in the Q&A box that you see on your screen, and we will get to as many of them as we can. You will receive a recording of this webinar after its conclusion. And with that, Song, please take the mic.
Awesome, great. Thank you so much, Nolan, for the warm introduction. Good morning, good evening, and good afternoon to everyone as well. My name is Song, and I lead the engineering organization here at NetBrain. I'm going to be joined by my colleague, Raj Jain, who's our pre-sales engineering demo lead. And we are very, very, very excited today to introduce to you our newest innovation in our NetBrain Problem Diagnosis Automation System, powered by 10.1. For this release, we went back a little bit to our purpose, right? To just remind everyone is what is the problem that NetBrain is looking to solve. And our purpose is to solve one of the last unsolved problems in IT today, which is to automate network problem diagnosis. So from working with our customers over the last decade plus, we still see that for a lot of the IT network teams out there, there are still thousands of tickets every week and every month that they have to manually resolve and diagnose. This is resulting in hundreds of escalations. And in terms of the resources spent, there's a lot of time, and as much as 2/3 of the time from the network teams are being spent on diagnosis. And oftentimes we go back to our trusted CLI to be able to access all these devices and to get to the root cause. And the problem from what we've seen is prime for automation. So 95% of the incidents are repetitive. And 50% of the issues can be prevented either through a combination of verify and validate, looking at misconfigurations, and so on and so forth. So today, we introduce the Problem Diagnosis Automation System. And what problem are we really trying to solve with PDAS and 10.1? Well, first of all is, if a problem was solved this time in hours, can we solve it next time with automation in minutes? And dare we say, can we even prevent the problem from happening next time? And this is what we started to try to solve with PDAS and 10.1. So introducing overall the system to you today, we're very excited to unveil our 10.1 release, which completes our overall system to automate problem diagnosis. To start off, we have the new intent-based overall PDAS system that builds intelligence from two ways. Number one is your live network to understand the configuration, the topology, and the data that's required to automate your problem diagnosis. And two is a new way to build intelligence from your past tickets and using that knowledge to apply to your future tickets to resolve, number one, new tickets and help them resolve it much faster. And then two, apply that intelligence to prevent future problems from happening ever again. As part of this release, we've broken up a lot of our innovation based on these 4 categories. The first we'll talk a little bit more about is the Google Cloud support that we added on in addition to our Amazon and Azure support we introduced in 10.0, and also for the first time introducing our IPv6 support. And in the building intelligence from past tickets, we built upon our previous innovation network intent and introduce an innovative way to scale automation to the rest of your network using network intent cluster. And in applying new intelligence in this automation to new ticket resolution, we introduced 3 new items. One is the new trigger automation framework, a ServiceNow app 3.0, and also incident portal enhancements that helps end users get more value out of the product itself. And then lastly is an improved preventative automation framework to now take that on automation and knowledge and to apply it towards preventative measures towards future problems. So a lot for us to get through today. So without further ado, I'm going to start off with the GCP and IPv6 support. from the industry, we see that a combination of a couple of factors. Number one is the public cloud adoption continues to grow in industry. And two, more and more of enterprises are currently using or plan to use a multi-cloud strategy. So from looking at the recent outages and as well as the challenges from a single cloud strategy, a lot of enterprises that we've seen and talked to are adopting a multi-cloud, whether it's multiple public clouds or with on-prem, to be able to mitigate the risks that comes with cloud usage. But one of the biggest complexities that we still see in the migration to cloud is the operational complexity and root cause analysis that's requiring a lot of team members to come together to collaborate on resolving something that may have gone through 3 or 4 different environments, an application path that goes over it. So what we are proud today is to introduce our GCP support to add to our Azure and AWS support that we introduced in 10.0. The other thing in addition is that IPv6 we see today more and more is representing more than 30% of today's internet traffic. So we see a lot of demand for our especially service provider customers to be able to support IPv6 in our latest product release. So with 10.1, we released both the GCP support as well as IPv6 support. First of all, from a GCP support, we introduced all the capabilities that you know and love out of the NetBrain data model and the map into GCP. So auto-discovering, documenting GCP infrastructure, including things like projects, VPC, subnet, firewalls, load balancers, interconnects, various different VPN, and as well as network virtual appliances. We're also able to use now this new support to be able to map applications and hybrid applications across hybrid environments, whether it's from GCP to Azure to AWS and back to on-prem, because we know application payloads and network payloads are spreading across all of these environments today. We've also integrated with the GCP cloud management tools, such as the firewall rules analysis and VPC flow logs, to bring that data right into the map for your consumption during design, during troubleshooting, and during diagnostic. And then you can use the runbook and as well as the QApp technology, automation technologies if you had in the past, to be able to help you troubleshoot GCP and as well as these multi-cloud environments much faster. And we also introduced that an auto discovery, we expanded auto discovery into the IPv6 space for you to seamlessly map your IPv4 and IPv6 devices together. So very, very excited for this part of it. Up next, we'll get into the crux of today's presentation, which is to really introduce to you how we build and use intelligence from the PDAS system. So to do this, we want to talk a little bit more about intent, and it's a little bit of a recap of what we talked about last time in 10.0. In our previous version, we introduced the concept of a NetBrain intent, which is to manage your devices, your network, not by devices, but with thousands of intents. And these intents are like strands of DNA that exist on every single one of your devices, governing your network flows. And these intents could be things like your primary global VRF BGP next hop IP should be Sprint. All of your SMP traffic should be disallowed on WAN interfaces. To MTU on your core-facing devices, to AAA authenticated users, to ACK CLI, and QoS policies, security filters, and so on and so forth. These are the key intents that govern and make sure that your network is able to accomplish the things that your users and your applications necessitate. And in 10.0, we introduced this innovative concept called the network intent as an automation unit to encompass all of the diagnostic knowledge into one automation unit. And it really comprised of 3 things. The first is the device that we want to do the diagnostic on. 2, of course, is the data. So these could be configurations, could be show commands. And 3, most importantly, is diagnosis through compare. So allowing us to take the data from these devices, either to compare against each other or compare against itself in history, to very quickly to be able to see what's changed and what could be causing the problem today. And today, we're very excited to take this problem one step further, which is now we have all of these type of network intent for any particular problem in your network. So it could be, hey, ACL between R1, R2 should be identical, or MTU for one particular device and interface should be 9,000 bytes. The challenge that we want to take on with 10.1 is, how do you now scale this and replicate these network intents from one single problem to all the similar problems in your network? So instead of looking at ACL between R1 and R2 in Boston, we want to look at ACL on all WAN pairs, and that they should be identical. Instead of looking just at MTU for one particular device in BOS R1 interface 01, we want to look at all core-facing interfaces, and that should be 9,000 bytes. And this is what we're very excited to introduce. It's the concept of a network intent cluster. And through this mechanism, we can accomplish taking your individual intents and replicating it across your entire network and generating hundreds and if not thousands of these type of intents. So enough of theory. Let's see this a little bit in action. Yesterday, I just received this email from our CIO. We had a major outage that impacted our business significantly. We later found out, and this is the email that I was sent, is the San Diego to Vancouver WAN link failed over last week, and that resulted in half of our applications not working. And I received the simple request of, can we make sure this never happens again? And not only for this site, but for all of our sites. Now remember, we have 50 of these type of sites inside of our enterprise. So how do we do that? Well, first of all, let's start with capturing the knowledge and the intents into one particular automation unit. So if I look at the example that I just had between San Diego and Vancouver, firstly, I would want to make sure that my San Diego WAN device should always be able to reach my Vancouver network. And conversely, I want to make sure my Vancouver WAN device should always be able to reach my San Diego network. I also want to make sure that between these 4 WAN devices, that the next hop, whether it could be Sprint, Verizon, AT&T, should always be the same. So they shouldn't change. And I also want to make sure that the ACL and the specific ACL in between the 2 devices, between any WAN devices, so either 2 in San Diego or both in Vancouver, should be symmetrical. And I want to make sure there's no configuration drift that occurs. Great. So this is how I would design the intent for one particular site. The next thing I want to do now is to parameterize our design and abstract that to all of my different sites. So really what I know is that this is a representation of not only San Diego and Vancouver setup, but this is a setup that I apply to all my 50 sites. So the first thing I can do is define them into groups of 4s. And I define that group as a WAN link group. And furthermore, I can define the different roles now. And each device represents either a network A's primary router, network A secondary, or network B's primary and network B's secondary routers. And this way, I can successfully parameterize what it is in one site into many others. Then I take this to the next step. And each one of these devices should also have a set of allowed networks. And also, they should also be remembering what the next hop IP should be, so I can always validate towards. And then I can even keep track of what specific ACL number do I want to make sure that they match. And in this case, it's 10 and 11. Through this way, I'm parameterizing my network design, but then through that, I can parameterize my intent as well. So instead of looking at San Diego devices should always have access to Vancouver, I can now say that network A's primary and secondary devices should always be reachable to its allowed network. Conversely, network B's primary and secondary devices should always be reachable now to its allowed networks. And then lastly, my ACLs should be within a network A's primary and secondary, and network B's primary and secondary WAN devices should be symmetrical. And if I apply now this logic and add on a lot more devices, so today it could be San Diego and Vancouver, I can now add in Dallas and Beijing as my second group, and maybe I'll add in Boston and Toronto as my third group, and so on and so forth. I can now extend this to my 10, 50 different WAN link groups, and that can replicate into 10, 50 different intents that now I can utilize to automate my diagnosis next time. So with that, I want to turn over to Raj to show you, and instead of listening to me talking slides, to show in our product how that's done. Raj, over to you.
All right, thanks a lot, Song, for that introduction. Hey everyone, my name is Raj, and what I'll do is I'll give you a quick demo of how the intents work. Now, we'll take the same portion of the network that Song referred to. So we've got 4 devices here. We've got the San Diego primary, the San Diego secondary link to our Vancouver location. And what happened in that scenario is that one of the primary links failed over to the failover link, and the failover did not respond the way it is supposed to, due to which the applications went down. Now, what we'll do to identify the impact here is quickly use a network intent. And I'm going to use the same network intent that Song was talking about here. So let me do this real quick. There you go. Great. Now, as soon as I use this intent, you'll see that the devices were loaded onto this intent automatically. I'm quickly going to run this. And under the status code, we can see that it's an error message, which is expected, given that message that Song received. Great. So let's take a deeper dive into the network intent to really see what happened. Now, just by looking at the network intent, the highlight of this network intent, I would say, is that error message right there, which says that the ACL of the Vancouver R1 is not consistent with its redundant pair. Now, let us first find out what is the device data diagnosis and comparison really mean, and then we'll jump into what this message really means here. So we'll start with the devices. So we've got all the 4 devices here as part of our intent. And across all these 4 devices, we're looking for similar information. Number 1 information, is it reachable to its destination? For which I see a lot of greens for all these devices, which probably means that yes, they're able to reach their destination. Check number 2, is the next hop IP consistent as the last time? So next hop IP has to remain the same as the baseline. And that also is not highlighted as an error over here. The third one here is to look for the ACL problem. So is the ACL consistent with its redundant pair? And if it's not, you'd be able to see an error message. So what have we done here? Like Song mentioned, we look at the device, then we look at the data. The data over here is to look for the access list. And then we do a compare. And we're comparing the access list of R1 to R2 to see whether or not they're the same. And in this case, they're different, which is why we're facing that problem. But this is just with these 4 devices. Okay, NetBrain was very quickly able to tell me that, hey, there's a problem between the 4 devices and I can go and fix it there. But what if this was a configurational issue across my network, on all of my routers, all of my WAN connections? How can I use the same intent and then replicate that across my entire network? And this is where the network intent clusters comes into picture. Now, the network intent cluster is a way to take a single intent and then use it across your network. And as you can see, this is a very simple wizard. You follow the steps of instructions given there, and with no code or low code, we'll be able to get to the destination here. So let's start with the first step, input. What does it need from you? It needs an input device from you. So we can either choose that from NetBrain, or like Song mentioned, there was a CSV file. I'm going to quickly bring that up. And this has a list of all of my WAN routers with their device roles, which is very important. We'll talk about this. The allowed network, the next hop IP, and the ACLs. So that's my input. Number 2, what does it need? It needs a sample NI, or the seed NI. And in our case, the network intent that we're using as a sample is the one that I just showed you a couple of minutes ago. The one that is looking for reachability, next hop IP, and the access list mismatch. And then what do you need to do? We've got the WAN devices, we've got the logic, but now we need to group those WAN devices. How would NetBrain know which one's the primary, which one's the secondary? So for that, we have to give NetBrain a sample. So what we've done here is we've taken the first one, for example, we said the net A primary is my primary A. And then similarly, we got the primary B, and secondary A, secondary B, and we've just done it once. And then let's say you've got 100 WAN networks. If I populate data, it's going to go and make those groups automatically for me. Okay, so in our case, we just have a couple of groups in our demo lab environment. But in your network, if you've got 50 different groups or 50 different pairs, you just have to do this one, and you can replicate the logic against all of them. So you got the input devices, you got the logic, you've created those groups. What is left? the last thing that is left is to run these intents. Okay, so NetBrain is smart. It takes those groups, takes the intent, and it's going to use the intents on all of those groups. The two groups that you see here is the one that we just looked at, the Vancouver and the San Diego. And the second one is Beijing and Dallas. Okay, so it was able to find those groups for me and was also able to run those intent checks. And I can easily see that the destinations were all reachable. However, the ACLs were inconsistent for both these R1 devices, which means there's a problem. Okay, so this is how simple it is. Step number one, create a network intent with absolutely no coding. Step number two, get a list of devices. Step number three, group them. Step number four, your intents are ready to use. And now I could use this intent across all of my devices in a cluster. So that's all from my end, Song. I'll give it back to you.
That's very cool. Thank you, Raj. That was very powerful. So not only do we see how the intents make the diagnostic so much easier, looking at reachability, very powerful logic, reachability, looking at ACL symmetry. I know this is something that happens in networks all the time, and seeing that replicated to the rest of the network. I know in our lab, we don't have a very large one, but seeing this kind of replicated to 10, 50 different sites, it's very powerful as well. Great. So next up is we want to talk a little bit about how we apply all that automation to any new tickets that come in. And the concept that we really want to focus in on this section is the trigger automation framework, our new ServiceNow App 3.0, and as well as enhancements to the existing incident portal to help engineers and network engineers and also IT engineers alike to be able to observe and interpret the diagnostic data that we provide. So in the previous section, we talked a lot about how you can replicate a set of intents into many, many different intents and creating a cluster using it. That intent was just an example. You know, we just looked at a very powerful diagnostic that happens over and over again, but that could be categorized into a design network intent cluster. And amongst the design NICs or network intent clusters, we could be looking at verifying whether or not our core devices have the identical routes to our production networks, whether or not QoS configuration for key applications are consistent across the devices within the primary and secondary path. We talked about the MTU example, and we talked about ACL. So in addition to design or automation applied to design, we can also apply this concept to security. So either from looking at whether or not particular security filters exist on inbound for all internet interfaces, for example, whether or not your DMZ network is or is not accessible from your enterprise segment, or the more of the kind of the blue collar type of validations and compliance to look at whether or not your telnet access in your devices is disabled or not. And also, we're starting to see that we can create NICs for well-known ticket diagnostic. Whether it's from high CPU, interface errors, BGP neighbor down, interface down, so on and so forth. We see a lot of common repetitive symptoms or issues from our customers. And there's a lot of them that we can build our network intent clusters to resolve. Now, each of these network intent clusters could have hundreds, thousands, maybe tens of thousands intents that goes behind it. As the bigger your network becomes, the more, as you can see, this replication logic can be applied to your entire network. Now, the challenge now becomes if there's a new ticket that comes in. So let's say, for example, in this case, in the previous, my CIO sent me the email was regarding San Diego and Vancouver. If another ticket comes in today that has those two devices, those two particular sites, there's a shared drive inaccessible between them again. Or tomorrow it could be Beijing and Dallas. How do I select not only the right network intent cluster, but also the right intent within that network intent cluster and display that onto our incident portal using the map, the diagnostic, and as well as the message? So with that, again, I'm going to turn back to Raj to really show this principle in action and how this will work inside of NetBrain. Raj, back to you.
All right, thank you, Song. Great. So for this portion of the demo, I would like to start with my incident management system that is ServiceNow. And we'll start with the ticket that Song was just talking about. the one that he got the message from the CIO for. The shared drive inaccessible between San Diego and Vancouver. So let's take a quick look at that ticket. Great, it's an ordinary ticket. I don't see lots of information. So probably I'm assuming what happened is help desk got a call from one of those locations saying that, hey, we're not able to access the drive anymore. Great, so help desk went in there, they created that ticket, and then they were done. So this is where NetBrain steps in. Now in a usual scenario, and of course in the companies that I worked in the past, the ticket sits there for maybe some idle time, depending on the priority of the ticket. Someone takes a look at it, there's escalation, and it takes a good amount of time for somebody to go solve that problem, okay? What we're doing here is NetBrain is now your first response engineer. And there's no idle time with NetBrain because as soon as that ticket comes in, NetBrain's on top of it, it looks at the problem, and then finds a diagnosis for it. So let's see what happened here. If you scroll down here, under the NetBrain automation, you see that the ticket was created inside of NetBrain, the diagnoses were triggered, and NetBrain was able to run the same intent we've been discussing, and the result was sent back to ServiceNow. Now let's take a moment here and understand the logic behind this magic. So the ticket comes in, and it sends an API call to NetBrain. NetBrain looks at the data, the ticket type looks like a shared drive issue. All right, so I'm going to go and check my automation library and look for similar tickets from the past. And maybe it found something. So as soon as it finds something from the past, it's going to go and see what are the troubleshooting steps associated with that ticket. And then NetBrain is going to perform those steps for you and send the data back here. So it's not just looking at a ticket and assigning people to work with, but it's actually diagnosing the problem for you. And imagine the kind of MTTR it can reduce for you. Okay, and we'll talk about the MTTR reduction in a little more details, but this is what exactly happened. Now, if I just want to take a look at the ticket, maybe I don't have access to NetBrain. I just want to quickly look at the portal. We've got two options. We got the NetBrain portal option and the NetBrain option. So let's quickly take a look at the portal. And this portal is specifically designed for teams that do not have access to NetBrain. So it could be your help desk, your IT team. Maybe if the network teams own the product, then maybe it could be the firewall team or anything else based on what security policies you've got in your company. But just as soon as I'm in the portal, there's three things done for me. Okay, map, message, and diagnosis. So let's look at the map first. NetBrain was smart enough to understand that, hey, looks like the problem's been happening on these particular routers, and then it draws out those WAN links for me. The second thing is the message. The incident pane on the right-hand side consists of a lot of these messages from ServiceNow, from people, from NetBrain itself, and we'll talk about that in a little more details. But it also has diagnosis. Okay, and in this case, it has performed one check over here. But what I'd like to do is, in order to explain this in more details, I would like to open the same ticket in NetBrain. There you go. So we've got the same exact look and feel from the incident portal. The only difference is you have full access here. So you can do further troubleshooting, invite other people to troubleshoot and all of that. So let's first look at the map. The map was created as a result of identifying host names or devices from that incident. And we'll talk about that also in a little bit in details. And on the right-hand side, we're looking at the incident pane. It tells me that ServiceNow created an incident. There's a link back to ServiceNow. It also tells me what type of ticket it matched in my automation library. I'll explain that also in details. It attaches a map to it, and then most importantly, it gives me the diagnosis. And this diagnosis is nothing but the same network intent that we're talking about: reachability, next hop, and ACLs. The only difference is, the last time I was very reactive about this. Okay, I got the email, I panicked, I opened the map, I used the network intent. Okay, it looks like there's a problem. But how about triggering this network intent? So the ServiceNow does this for me. It triggers NetBrain. NetBrain looks at the intent, executes that intent, and boom, I know exactly what happened. So even that troubleshooting time has been reduced by a large amount now. Okay, great. Oh, there you go. And the last but not the least, we can also, again, we have major enhancements in the incident portal. I absolutely love this because this is exactly where I can invite other people to come troubleshoot with me. Okay, let's say, for example, there you go. Let's say, for example, I wanted to type in a message and invite Song to help me troubleshoot this problem further. So I'm going to say, Song, please help me. And there you go. As soon as I send this, it's going to reflect in my portal as well. So if Song is over here, there you go. Song is asking me a question, and I'll be able to take a look at that as well. Great. So incredible. Think of it like your Google Docs, right? If 4 of you all are working on the same document, you're able to see each other live. So this eliminates the need of me sending out emails and tagging people and waiting for people to respond. None of that. So we're making sure that there's no gap in that troubleshooting. As soon as a ticket comes in, we're going to treat that as priority and help you solve the problem end to end. Okay. Now, we've spoken about the intents, we've spoken about the ticket coming in, but how did everything get connected? And everything is connected using our trigger diagnostics center and our trigger diagnosis framework that Song mentioned about. And this is the most simple logic here. Just 2 steps. Step number 1, define the ticket type, the incident type. Step number 2, attach an intent to that ticket type. So step number 1 is very simple. It says shared device, shared drive issues. Good. So it's going to go in there, look at the short description of my ServiceNow ticket. So in this case, it's going to look at this short description right here, and then it's going to go look for shared drive. If it's there, great. And then of course you can add more logic to it, okay, if you want to be more specific. Next, once it knows it's a shared drive problem, it's going to go look at the config item to see if it matches to one of those intent devices, okay, one of those routers. If it does, we know exactly what area of the network we're trying to target. And the next thing we do is we execute the network intent and then insert that map into that ServiceNow. That's it. So very simple, 2 different steps. Step number 1, your ticket type. Step number 2, your diagnosis. And the cool part about this is a one-time work. Again, there's no coding required to do this. It's just logic. Okay, I did this once, and for every ticket that I'm going to get for the rest of my life, this diagnosis would happen. And imagine, even if this happens like 50 times, that's 50 engineers' work that NetBrain has done. That's our trigger automation framework. Super powerful. With that, I'm going to hand it back to Song.
Fantastic. Thank you, Raj. That was very powerful. I can imagine a lot of these tickets are very highly repetitive, and oftentimes it's both the knowledge of what to look for and also what the diagnosis is. And all in one, we're able to encompass them into a singular automation and can be reused at any time a new ticket comes in. And the fact that we can almost, so to speak, parse the tickets and identify the right intents within NetBrain, very, very powerful. So, and that brings me to the last, but definitely not the least portion of our PDAS problem diagnosis automation system, which is now how do we use these intents to prevent an outage from occurring and also impacting your business moving forward. So to do this, let's talk about the example that we just talked through. In this particular instance, we had a device failover, route failover from San Diego, from R1 over to R2. We know that it was the issue had a ACL 10 configuration drift between R1 and R2. So when it failed over to R2, a bunch of applications got blocked, and in this case was the shared drive amongst others. A lot of times the failover we're not able to predict or to prevent, right? It's, this is something that happens common in the network. We know the networks today, all the critical points, there's no more single points of failure. So failovers happening is not a bad thing. However, how do we prevent the configuration drift next time? And this is where in our new improved preventive automation framework is we introduce the concept of being able to design an early warning probe. And in this case, it could be when the San Diego R1 configuration has changed. And it allows us to alert us is that if R1's configurations has changed, make sure to check whether or not R1 and R2's configurations, especially the ACL, is it still symmetrical. And this could have happened a week, a month, it could be 3 months before the actual failover occurred. And this is able to resolve a ticking time bomb that could be in your network. And if the ACLs and the intent is deemed to be violated, we can now create a ServiceNow ticket to alert our engineering team to remediate the problem. And once they remediate it, they resolve the configuration drift. So when the failover occurs, we would not have the application outage. To take this example and express it across the entire network. So we take our library of network intent cluster we just talked about, from design, security, to well-known ticket diagnostic network intent clusters. And these thousands, if not tens of thousands of intents we created based on these clusters. What if we're able to create a bunch of early warning probes, such as this one that we talked about, is where we look at if R1's configuration's changed, and be able to identify the key intents that we want to validate and proactively able to create a design violation ticket. Through this, we're able to prevent a lot of issues from impacting the business before it even gets there. Configuration change is just one type of many early warning probes. So in addition, we could also be looking at network dynamic changes. We could be looking at whether or not our OSPF database version has changed, whether or not the number of neighbors have changed. We could also even be looking at typical performance type of metrics. If the bandwidth utilization on our secondary router becomes over 30%, we must know there's a state change within the network that deems that we should validate these intents to make sure everything is still good to go and doesn't impact the rest of our business. So with that, I'm going to turn over to Raj for one final time to show you how we can use the PDAS system to prevent problems from impacting the business. Raj, on to you.
Awesome. Thank you so much, Song. Great. So for this portion of the demo, I would like to start with the Preventive Automation dashboard. And this dashboard is incredibly powerful because my network could be huge. You can see I've got 1,167 devices, but we have customers with hundreds and thousands of devices as well. So what this does for me, it summarizes my performance, the performance of my network, and of course, reds and greens. So here, out of all these intents and all these probes running in the back, I was able to find 3 intent alerts in my network. And just by clicking that, I can quickly see what these 3 devices are. And one of those devices is our San Diego router. Great, so let's take a look at that and see what's been happening. So like Song mentioned, the automation probes over here are very powerful. Okay, think of them as probes that are sitting in the back, and according to a schedule, they're gonna go out there and look for a certain either configuration change or a state change or topology change or anything based on what is configured there. In our case, it's a configurational change, and it's going to go generate an alert if the current configuration is changed compared to the previous configuration. And very simple, it runs every day, and we can change this frequency, by the way. But configuration change is not a bad thing always, right? Maybe it's an intended configuration, but an outage due to a configuration change is a bad thing. So that is exactly what we have to be preventive about. So how do we do that? Very simple. Remember those network intents we have, which is going to go look for problems. First, we spoke about manually triggering them. Second, we spoke about triggering them through an alert, like a ServiceNow or something else, like a third party. But now we'll talk about being preventive about this and then triggering them in advance. So how do we do it? We'll use the configuration probe over here. As soon as this is red, which means some kind of change has happened. So what we'll do, we'll automatically go and run a bunch of intents to verify if that change is impacting any business critical application or if it's violating any of the rules that you've set for your network. And it does, it did. And one of this is right here. I'm going to quickly pull it right here. And by now you're very familiar with what this is. We were able to find that there's a mismatch of that ACL. Okay, so imagine the reason Song got that message today in the morning about that problem and the failure with the shared drive is because we were not proactive about the whole thing. We did not know when that failover happened. We did not know when that ACL was changed. And as a result, today there's an outage. So how can we prevent the whole scenario? We're running these probes in the back and not just looking for ACLs, but looking for any other configurational state topology change in your network. And as soon as something changes, we're going to verify that using our intents and then find out if something changed. And how do you find it out? If an intent triggers an alert, we can send that alert to ServiceNow. So instead of receiving, I would always be happy receiving these kind of alerts than receiving an outage alert. Okay, so as soon as this happens, ServiceNow shows up. Let me go back and see if I can quickly. There you go. So these are all the rule violation emails that I've been getting from NetBrain. Okay, based on some of them are QoS, some of them are ACLs. Let me open one of these real quick. And very simple. It says, hey, rule violation happened. This is the device. Okay, Boston R2. Great. So this now this problem is happening in Boston as well. The same thing, ACL consistency. Okay, and ACL is not the same, and I've got the link to those devices. Now I can go and diagnose this problem. So even before I could get an outage in Boston, guess what? I actually received this violation rule, so I can go and fix this problem and preventing that outage. Okay, so that's our preventive automation in action. Super powerful. And with that, I'm going to pass it back to Song to wrap this up.
All right, fantastic. Thank you, you can see our vision is some strategically positioned probes in around your network can really give you the early warning system to trigger these intents to be run. And one of the things that we thought about when we developed this particular system is that what's the best way to lower the load on the network, as well as to lower the load for the user to interpret all these results. And this early warning system is a really good is a really effective tool to be able to go and trigger the different intents this way. Very cool. So let me summarize quickly is then what did we actually do today using our PDAS system? So we took a particular problem that my CIO sent me, which is a type of ticket really of shared drive inaccessible or key application is inaccessible. I took one particular representative problem, which happened on San Diego and Vancouver, and I turned that into a network intent, encompassing all the knowledge a senior expert network engineer would do to try to validate what the problem is. And then I used our new network intent cluster to replicate the sample network intent I created for this representative problem over to all possible instances. So the 10, 50 different sites with dual WAN links, all of it now replicated with now this network intent that can be applicable to them. So it could be San Diego today, could be Dallas tomorrow, San Francisco, Munich, and so on and so forth. We've also shown how a future ticket coming in can also use the trigger automation framework to find the right network intent cluster, as well as the accurate network intent, and be able to send that information into the incident portal to be consumed by the network engineer on the task at that time. And this engineer now will have all the knowledge and all the expertise that the senior engineering used to build into the original network intent, now that's replicated across the network. And just now, Raj just showed us how strategically positioned early warning probes, and one such example is to look at whether device configurations has changed. And when that configurations change, it could be, this device could have a configuration change every day, every week, every month, maybe only twice a year. But when that happens, we can allow that to trigger key network intents on those devices, whether it could be looking at if it's part of a strategic WAN link, in this case, looking at ACLs. It could be having a QoS configuration configured on top of the device. We look at whether or not QoS symmetry is there on a key application, or it could just be looking at common things like MTU and SMP. All of that now can be triggered using this probe whenever that configuration is changed. And if there is a violation, we're able to open a ServiceNow ticket. And like Raj said, these are probably the best tickets that we can have, is where there's an intent violation and there's no urgency and no the sky is falling yet. We're able to resolve the issue before it really, really impacts the business. So we come back to what problem were we trying to solve with 10.1 and PDAS? Well, one is if a problem was solved this time in hours, can we solve it next time with automation in minutes? And dare I say, yes, we are able to. So any new ticket coming in, we can use the new trigger diagnostic automation system to find the right intent validated towards faster diagnosis. And two is, can we prevent the problem? And these early warning probes triggering our intent can also help us prevent these issues from impacting our business fundamentally. And then just to remind us our original ask from our CIO, can we make sure this never happens again for all of our sites? And the answer now is resoundingly yes. This is just the beginning, and there's a lot of improvements in NetBrain 10.1, including the introduction of a new open topology and data accuracy system that will help all of us improve our data accuracy that becomes the foundation of our system. The GCP and IPv6 support we talked about, more collaboration enhancements, introduction of different reference and personal maps, new parser discovery, visual parser improvements, administrative security, and so on and so forth. Much more enhancements in 10.1. And we'll be making all this available on our website dedicated to 10.1 and also the PDAS system. And with that, just one more thing is we're very proud to also introduce for the first time our NetBrain Automation Library powered by Intent. Through working with you, our customers, as well as the industry, we've identified common automations as foundation of our library. Now, these could include NICs for well-known tickets, and its common design security rule templates, different types of maps that should be created for different types of incidents. We generated now, we're creating a library now, and we've continued to invest in improving this automation library to be made available to you, our customers. This will be launched after our 10.1 release, and we're really looking forward to you participating in this with us. So lastly, what's next? Number one, learn more. There's a lot of different new innovations within the system, and we only scratch the surface here. But hopefully through this webinar, you're able to see what we're really truly able to do now with a 10.1 innovation. To get more into detail, please request a demo. Once a member of our team will be happy to work with you. If you're an existing customer today, we're going to be making our upgrade request form live today. And the release itself will go GA in the next couple of weeks, and we'll keep you in the loop and informed as we move on to when we can upgrade. And lastly, read the latest news. In our website, and we look forward to also hearing some questions and answer them. Thank you.
All right, thank you all. With that, we have about 10 minutes for Q&A. And I saw a number of good questions come in through the chat. And let's get started with the first one. When can we get 10.1? Song, if you want to take that one.
Sure. Thanks, Nolan. So as I just mentioned a little bit before, it'll be coming out in the next couple of weeks. Currently, we have targeted for Pi Day on March 14th as to make it available for the upgrades to start. But I really encourage everyone to head on over to our website, make that request, and we'll be in touch with you shortly thereafter as well.
Excellent, thank you. And the second question, which module of NetBrain provides the PDAS functionality, everything we described here? Is it IBA or intent-based automation?
Got it. And I'm just looking at the question, and this came in a little bit earlier in the webinar. I'm looking. Okay, so great question. So the NIC, one change we did make in 10.1 is we made the capability of the NIC, and as well as the preventative automation that we just talked through the early warning probes and system, et cetera, available through the base license. And it will have a usage cap, so a set number of intents run per day. We now position our IBA license to remove that usage cap versus previously. So we did this so that customers can get immediate value right away, even if it's on the base license without the IBA module. And then with more and more value and more intent runs and diagnostic runs throughout the days, and then having the option to pay to open that up for much more usage across your entire network.
Very good. And I know this was covered in the webinar itself, but just in case anyone missed it, how does one get a demo for the PDAS platform or anything in NetBrain?
Sure. I think the easiest way is most likely to go through our website and register for a demo there. Now, if you're an existing customer, please go through your account executive, get in contact with them, and they'll be happy to schedule a demo for you. But for new customers and anyone that wants to join kind of our community, I think the website is probably the best way. Not sure, Raj, Nolan, if you guys have other thoughts there.
I would agree. There is a form on netbraintech.com. Please submit your request there, and we'll have someone reach right out.
Great.
All right. Looks like we have one more question. And by the way, if you have questions that you've thought of, please enter them into the Q&A chat. We definitely have a few minutes, and we'd love to cover them for you. But the last question we have right now is, what type of access to devices is needed for the type of visibility and analysis that we covered in this webinar? What if your organization only has access to RO, SNMP? I believe Raj, you can take this one.
And I'll take it in lieu quickly. So just to answer that particular question, so we have to get the full capability of our system is SNMP, CLI, or API, depending on what's the best way to get data from your systems. For much of what we did today, there's the NIC. It uses a mixture of SNMP and CLI information to read the configuration files, as well as the show commands and et cetera, to be able to get that.
Very good. We did just get a question. Is the webinar available on demand? Yes, this will be available on demand after the conclusion. Also, anyone who registered will receive a copy of the webinar, so you'll definitely be able to view it again and again. And then we have about 5 minutes. So actually, I have one last question for the team, unless we have any other questions come in from the audience. Definitely saw a lot of great capabilities for addressing network troubleshooting tickets. I would like to ask our group of panelists here, what other capabilities are there of NetBrain to use these capabilities to address network tasks aside from troubleshooting tickets?
Sure, that's a good question, Nolan. I can maybe kind of take that one too. I think over the years we've seen our customers really use, I think, the foundational features such as especially the discovery engine, the map, and as well as the different automations for all kinds of tasks within the network lifecycle. So the kind of Cisco's PPDIOO, we've seen it all across the board. So whether you're an MSP that's taking over a new network and wanting to know what it is that you're taking over, our discovery really helps with that. Whether you're maybe designing a new change and wanting to do collecting the baseline configurations and data before and after the change, do that comparison. A lot of the day one type of tasks, we see a lot of customers doing that as well. But by far, I think the customers that get the most value is really in utilizing all the data and all the automation that we just depicted today, and as well as our previous versions and features in troubleshooting and in rectifying and in problem diagnosis, and especially after the integration is done. But I think we see ourselves as that we have the foundational data model platform, and then all the kind of the mapping automation that comes on top of it that can satisfy a number of different tasks there.
Absolutely. A lot of great use cases with NetBrain, and definitely provide tremendous value in network troubleshooting. But wanted to point out that we extend even further. So it looks like we have time for one more question, and we have one more that came in. If you have a cluster of devices and want to compare the port configurations regarding 802.1x, would it be possible to define exceptions such as don't check port 7, 9, and 12 of network switch X?
That's a great question. So and just to kind of maybe to repeat it. So it's someone's the question is, if there's a cluster of devices and they have common configurations on 802.1x, is it possible to find the intent to make sure it doesn't, for example, check the kind of specific ports on the clusters and the switches in the cluster? I think Nolan would want to make sure that that's okay. Great. So the answer is absolutely yes. So it would be actually, this is a great topic to maybe kind of dive into in a particular demo. But we can do that and also be able to do it through no code. So what we'll be able to do is actually dynamically find that cluster of devices based on a set of different criteria that you give it, and then be able to pull its interface configurations in that case, be able to parse out and specify what should be included and what should not be included, and then be able to replicate that across your entire network. So it's a very powerful piece, and it's a very interesting use case that I think would be really good to dive into on the customized demo.
Absolutely. All right. Well, that takes us to the end today. I want to thank everyone for their time and attention. And as I mentioned, we will be sending out a replay of today's webinar. So again, thank you for your time. Have a wonderful day, and we look forward to seeing you again. Take care.